Hello, this is our fourth of four videos of Chapter 4, Section 1. This section will be building linear models from verbal descriptions. Okay, let's begin. So modeling with a linear function. As always, the average rate of change of a function is constant m. A linear function f can be used to model the relationship between two variables as follows. F of x equals mx plus b, where b is the value of f at 0. That is, b is f of 0. So if you plug 0 in to the x, you'll get m times 0 plus b, which obviously is b. Okay? So let's look at an example here. It's called straight line depreciation. Alrighty? So book value is the value of an asset that a company uses to create its balance sheet. Some companies depreciate assets using what we call the straight line depreciation, so that the value of the asset declines by a fixed amount each year. The amount of decline depends on the useful life that the company assigns to the asset. Suppose the company just purchased a fleet of new cars for the sales fleet at a cost of $31,500 per year. The company the company chooses to depreciate each vehicle using a straight line method for over 7 years. This means that for each car will depreciate by $31,500 divided by 7, which is $4,500 per year. Okay, so that means when they bought the car, it was worth $31,500, but then 1 year later, it's going to be $4,500 less than what they purchased it for. Now, you and I both know, if you've ever bought a vehicle, cars don't really do this, but this is for a company to keep the balance sheets equal. Okay, so what they're trying to say is, because some cars, if you put a lot of miles on it, if you could buy two cars the same year and put different number of miles on it, it's going to be, one's got more miles on it, it's going to be worth less than the one that had less miles on it. And that takes a difference. And then plus, most vehicles these days, when you drive it off the lot, you take a huge hit in the value of the car. I mean, initially when you drive it off the lot, some people say you can lose 10 to 20% of the value of the car after just 1 day. So, but that's not what we're talking about here. This one here, this company is taking $4,500 off the price of the value of the car each year. So eventually on year 7 in this example, the car will be worth nothing. Okay, so write a linear relationship that expresses the book value of V for each as a function of age, which x is in years. And then we're going to graph the linear function. We're going to, what is the book value of each car after 3 years? What we're going to do is interpret the slope. What does the slope mean when you found the answer to the linear function per day? And then when will the book value of the car reach $9,000? In other words, we're going to solve that equation, V of x equals $9,000. Okay? All right. So here we go. Here's the first one. We're going to figure out that linear relationship. If we let V of x be the value, represent the value of the car after x years, remember V of 0 represents the original value, which is going to be $31,500. That's your B. The y-intercept of the linear function is $31,500. Because each car depreciates $4,500 per year, that's going to be your average rate of change. And this is a linear relationship, because it's called a straight line. So the slope is going to be negative $4,500. So the linear function that represents this book value is going to be V of x equals negative $4,500 plus $31,500. And it makes sense, because if x is 0, as soon as you drive it off the lot, it's $31,500. But 1 year later, you plug negative $4,500 times 1, add $31,500, and then the car is going to be worth, $27,000. So that's the idea. So in year 1, the car is worth $2,700. Year 2, you can imagine, well, you just have to plug 2 in and see what happens. So this is a linear relationship. That's your equation, though. Part B. This is now the graph. So we know what the slope is, negative 4,500. We know what the y-intercept is, and there it is. Now I want you to notice something about this. It's a line. Yes, it is a line. But they don't have the graph extending infinitely in both directions, do they? They have it stopping on the y-axis and they have it stopping on the x-axis. Why is that? Well, if you went past the y-axis to the left, then your x is a negative number. What is x? X is the age in years. The car cannot be -1 or -2 years old. So that's why they have the graph starting on the y-axis at x equals 0. They have it stopping on the x-axis at 7, don't they? They don't have it going below the axis into the fourth quadrant, do they? Why? Because if extended in that direction, the value of the car is the y. That means the value would be negative. And the car is going to be worth a negative value. So you cannot be, the smallest it can be worth is $0. Okay? Now that's what the relationship is. Okay? So what they did was they knew the initial value was 31,500, and they knew that at year 7 it would be worth 0. So that's why they put those 2 points there, and then they connected with a line. Okay. Notice there's no additional points in between in the first quadrant, are there? They just found the starting point and the ending point is what they did. Okay. Step C. The book value of each car after 3 years is, plug 3 into the formula. So negative $4,500 times 3 plus 31,500 is going to be, what is that, around $18,000. And that looks kind of like what the graph is indicating. If you look at age 3 and go up the chart, it looks like it hits around 18,000. So the graph is pretty accurate. Now, step 4. Since the slope v of x is negative 4,500x plus 31,500 is negative $4,500, the average rate of change of the book value is negative $4,500 per year. So each additional year passes, the book value of the car decreases by $4,500. And you're like, what are they asking here? Well, they want us to interpret the slope. Remember, that was part D. They was wanting us to interpret the slope. And the slope is negative 4,500. And what that basically means, each year the car value declines $4,500. Simple as that. Okay? And then E, we want to find the book value. When the value of the car is $9,000, what is the X? So what year is that? How old is the car? So they put the value at $9,000 and they set that equal to the function v of x. They solved for x. They subtracted 31,500 and then divided by negative 4,500 and they got x equals 5. So that meant the car is 5 years old when it's worth $9,000. So it's a pretty easy explanation here. But it's a linear relationship. That's all there is. That's all that is. All right? Now let's look at another type of a linear relationship called the supply and the demand. Okay? The quantity supplied of a good is the amount of a product that a company is willing to make available for a sale price at a given price P. The quantity demanded of a good is the amount of the product that the consumers are willing to purchase at the given price. Suppose that the quantity supplied S and the quantity demanded D of widgets are given by the following functions. So the supply based on a price is going to be 40 times P minus 200. Okay? So for example, if you set the price at, let's say, $10, then the consumer, not the consumer, but the company is willing to sell 40 times 10 minus 200, which is 200 items. So they're willing to make available 200 items. But if you set the price at $10, the consumer demands negative 20 times 10 plus 1,000, which would be 800 items. So if we set that price at $10, the company is willing to make available 200. But if you set the price at $10, the consumers are willing to buy 800 items. See the problem? Consumers are wanting to buy 800 because you set the price at $10, and but the company says, well, this price is too low. I'm only going to willing to make you 200 items. Okay, well, let's raise the price up to say $20. Okay, well, in that case, the company says, okay, now you do 20 items, so it's going to be 40 times 20, which is 800, minus 20, which is 600. Okay, so now you set the price at $20. They're willing to make you 600 items. But the consumer says, okay, well, negative 20 times 20 is 20, plus it's going to be negative 400, plus 1,000, which is also 600. They are willing to purchase 600 items. That sounds like a good deal then, doesn't it? Okay, but what happens if you set the price at $30? Well, $30 is, the company is going to be very happy because 40 times 30 is 1,200, minus 200 is 1,000. So they're willing to make you 1,000 items. But the consumer says, wait a minute, 30 items? No, negative 20 times 30 is negative 60. Negative 600 plus 1,000 is 400. They're only going to be willing to purchase 400 items. So in that case, the consumer is not going to be buying as many. The price is set for the company's advantage because they're going to be willing to make you 1,000 items, but not the consumers are not going to purchase that many because the price is too high. So what we're trying to do, we ran across it when we were using these numbers, we want to, when it hits that same number, we want the consumers to be happy and the company to be happy. And that's called the equilibrium, and we'll talk about that on our next slide. And I think we ran across it when we were just putting numbers in here. Well, P is the price of the widget though. Okay, so let's move on. It says the equilibrium price of a product is defined as the price at which the company, the quantity supplied equals the quantity demanded. That is the equilibrium price and the price of in which the supply at the price and the demand at the price are the same. So what we want to do is find the equilibrium price of widgets. So what is the equilibrium quantity and the amount demanded or supplied by that equilibrium price? Well, we got to set the supply and the demand to be the same. So 40p minus 200, okay, and that was the company's function, and negative 20p plus 1,000, which was the consumer's, the demand function, and we set them equal. We start solving for p, and then we end up with p equals 20. Remember, we ran across that number a second ago. So that p is $20. That's the price that needs to be set by the company, so they will basically sell all the items that they produced. And then the consumer, that's the number of consumers that wants to make. So, so that's what it is. So the price needs to be set at $20. That means when you put 20 back into the functions, okay, the equilibrium price is $20, then remember that's the price that needs to be set. And if you remember, we did that a while ago, and I think it was, 600, wasn't it? So 40 times 20 is 800, and then 800 minus 200 is 600. So 600 items needs to be produced, and if you set the price at $20, the consumers will purchase all 600, and everybody's happy. Okay? Now the next one is we're going to determine when the prices for which the quantity supplied is greater than the quantity demanded. That is, the price, solve the equation S of P is greater than D of P. So this is when the supply is going to be more than what's demanded. Well, if you solve that problem, I believe it's going to be greater than 20 because we set P equal to 20 a while ago. So P is greater than 20. That means if you set the price more than $20, the supply side will be higher than the demand side. What does that mean? the company is going to have leftover products. Not all their products will sell. The company is not going to be happy. They're going to lose money. So if they set the price greater than $20 though, that's what's going to happen. So if the company charges over $20 per widget, the quantity supply will exceed the quantity demanded. In this case, the company will have excess widgets in inventory. Okay? Now, we're going to graph both functions, S and D, and see what happens. And then the equilibrium point is the point of intersection. Okay? So here's the solution. So the figure shows the graphs of the supply and the demand. Remember, the supply is 40p minus 200. And then the demand one is negative 20p plus 1,000. And notice, neither of these lines exceed past the x-axis and the y-axis. Okay? Because you cannot have a negative number of widgets, and the price cannot be below 0. Alrighty? So notice where the two graphs cross. They cross at 20,600. And that's kind of what we said, wasn't it? It said 20 items, $20 for the item. It's going to sell 600 items. So to the left of that, to the left of $20, the consumers are going to be happy because they're willing to buy more. But the problem is the supply will be lower than the demand. So they won't be really happy because the company says, I'm not going to make these items for you, that many items for you. So the demand's high, supply is low. But on to the right of that one is the supply is high and the demand is low. So the companies are striving to find that equilibrium point. They don't want extra items in their inventory, but they don't want unhappy customers either. So if consumers are not getting the items that they want, they're going to be unhappy with that company. So they're trying to hit that equilibrium point. But they don't want to set the price too low, because if they set the price too low, that means the demand's going to be really high, and they're not going to be willing to make that many. So it's got that fine point for them. All right. All right. Now to find the equilibrium quantity, evaluate SP or DP at 20, and that's going to be 600 as we illustrated there. And at a price of $20 per widget, the company will produce and sell 600 widgets each month and have no shortages or no excess inventory. So they're happy, customers are happy. All right. So that concludes this fourth of 4 videos of Chapter 4, Section 1. You have any questions on that one? You probably see a few examples that are very similar to the one I'm just showing, ones I've showed you here. So if that's not enough, look in the author's videos. They show additional videos as well. But if that's still not enough, as always, you know to contact me. And just give me a problem in the book that's kind of illustrating what you need help with, and we'll go from there. And we'll go and put some student request videos in there to pad that up a little bit. So, but as always, you have a good day.